In this video, we are going to talk about embeddings, how they work and what type of problem they solve. So first, I want to give you one practical example. If you head over to LinkedIn learning platform, on this left side, you'll find this AI assistant named AI coaching. Here you can ask any sort of information related to data exist on LinkedIn learning platform. For example, if I want to ask something like this, I want to learn dev oops. When I hit enter, AI is working in background. AI is processing this prompt. AI is understanding each token in this prompt and meaning behind it, and it is recommending us these topics. So what is happening here? AI is recommending us some relevant information based on our prompt. So embedding is used for this kind of problem. Embedding is used for recommendation. It is used for search problem where we want to search through a huge repository or a database. It could be used for clustering where we want to group together similar objects. It could be used for anomaly detection. We talk about that as we proceed through this video. It could be used for classification. So there are various use cases of embeddings. Now let's see how embedding work. So let me give you one example. For example, you have a dictionary, and in this dictionary you have 10,000 words. Okay, so each of these words in this dictionary is let's say sorted from A to Z, and each word has their corresponding embedding vector. Okay, so let me give you one example. Okay, so let's say I have this line, I want apple, and here I want to predict next word. Okay, so I want apple. So what is next word could be used here? For example, we could use here juice. I like apple juice. And let me write another line, I want orange. So what could be next word after orange? Obviously it could be something like juice. So AI model can easily understand what is next word if AI knows the embedding vectors of each word. For example, in this dictionary, apple would be on top, somewhere on top, and orange will be somewhere in bottom. They are so far from each other, there is no relation between these words. If we create their embedding vector, what we can do, we can find some relation between each word, and how this relation is calculated, we talk about that in next segment. Let's see another use cases. So let's see how ChatGPT process our prompt. For example, if we write some sort of prompt, for example, I like playing guitar. So this is input. This input first went through the process called tokenization, where each word in this input is separated. For example, we have this input. So this input is first tokenized into a list of token, like I like playing guitar, just like that. So what happened here is this input is converted into a list of token, and then each token is converted into their corresponding embedding vector. Let's say this is embedding vector 1, this is embedding vector 2, this is embedding vector 3. Alright, so what are embeddings? Embeddings are the multi-dimensional vector representation of a word. It is used for problems like search, clustering, recommendation, and different type of problems. So in this segment we talked about embeddings, what is application of embeddings, what they are, and in next segment we are going to talk about how embedding find that meaning, that essence, or that context behind a word. In previous segment we talked about embeddings and various applications of embeddings. Now we will try to understand the true meaning of embeddings. So we are going to decode an embedding vector. So first we will see what is a vector. and then we will see what is an embedding vector, and finally we will see some really nice applications of embedding vectors. So very first thing you should know is what is a vector. So a vector is something which has a direction and a magnitude. For example, let's consider very simple example, okay, 2 I cap and 3 j cap. I and j represent axes, and I can easily draw this vector in 2D plane. Let's say this is x-axis, this is y-axis. So in x-axis I will go 2 unit, in y-axis I will go 3 unit, and the resultant would be a vector, and this vector has a direction with respect to x and y. Let's say some angle, let's say angle 60 degree or 30 degree. Okay, so I can represent this vector in form of matrix as well. So I can write it like this: 2, 3. Let's say if we have a third axis, g axis, let's say we have a 3D plane. In that case, vector would be something like this: 2, 3, 4. So let's add one more value here, 4 k cap. So in a simple vector, each of these value represents an axis, but in case of large language model, in case of GPT models, each of these value represents something else. So what is that something else? This is the point of this video. Okay, so let's say we have a word king, then this word king is going to have an embeddings. Okay, so we are going to use GPT model to create embeddings of this word. So in this embedding we are going to have floating point numbers, let's say f1, f2, and let's say it has a length of 2000. So it is up to 2000. Then each of these value f1, f2 represents the relatedness of this word king with respect to certain parameters or attributes. So let's see what are these parameters and attributes. Now we are going to create an hypothetical table. In this table we are going to create an embedding matrix or an embedding list. Okay, so in this column we are going to add some parameters, and we are going to compare those parameters with these word, and we will see how close these parameters are with respect to this word, and we are going to score them, okay, from 1 to -1. If value is 1, that means they are highly related. Value is -1, that means they are highly unrelated, and this is just an hypothetical table. Okay, so let's see. Very first property or attribute is let's say gender. We know that apple and orange do not have a gender, so these value would be, let's say, 0.08, 0.07, or maybe in negative. And value for king and queen would be let's say 0.98, close to 1, 0.97. so gender and queen are highly related, and their value are close to 1. Alright, so let's add another property, taste. We know that we can't taste these two these two words, right? So their value would be 0.07, let's say 0.065, and their value would be close to 1, 0.97, let's say 0.96. This is how we can create an embedding matrix. For example, if we have embedding, we have this word king, then its embedding will be all these values, 0.98, 0.07. If we have here 2000 property, then this matrix is going to have 2000 values. This is how embeddings are created. For example, in this example, text to embeddings. First let me clear this output. So in this example, what we are doing, just a sec, we are converting this word hello into embedding list. If I run this step, you will see in bottom I am getting a list, or we can say a matrix. Okay, so how it is calculated with the help of OpenAI API. So OpenAI API provide different models. We have 3 models in OpenAI API. So these 3 models are very first model is text embedding small, and then text embedding large, and the one we are using here is text embedding ADA 002. So what happening here is we are using so first we are installing OpenAI API, then we are importing few stuff. We are importing this .env this load.env function from this package.env, so that we can load this env variable, and inside this .env file we have OpenAI API key, so that we can authenticate to OpenAI API. If you want to create your own key, you can head over to platform.openai-api/keys. Here you can click this button, create new secret, and here you can add a key. For example, let's say text to embedding key, and you can then just click this button, create secret key. And here is the important thing: once this key is generated, you should copy this key straight away, because after clicking this button done, this key would not be visible to you. Obviously you can create different, you can create another key. Alright, so in this example here we are authenticating to OpenAI API, and we are creating an instance of this OpenAI function, and then we are just using this embeddings and then this create method to create embedding for this word. Now important thing to note here is that in this function create, we pass two parameter. One is the input and another is the model. There could be another parameter, but these are two parameter which we should pass. Okay, so very first parameter is list of word or token. If we have a sentence, let's say I like apple, so this prompt is converted into tokens like this, and for each token embeddings is created. So the response of the embeddings API would be like this. So in response you are going to have a data object, and in this data object you are going to have embedding for each of these words. For example, you have embedding for word, let's say I, you have embedding for word like, you have embedding for word apple. Alright, so first let's run this. So we ran this last piece of code, we got this list, and let's see what is the length of this list. The length of this list is 1536. That means we have these many properties. We have 1536 properties in OpenAI model, and then an embedding vector is created for each of these words. So this is a very simple example. Okay, now let's see another important thing, which is cosine similarity. Let me clean this up. Here we will see what is a cosine similarity. Okay, so if we have two vector, let's say v1 and v2, if these two vector are quite similar to one another, for example vector king and queen, then the gap between them or the angle between them tends to 0, right? So the cos of this value, cos theta, would tends to 1, because if we draw the graph of a cosine theta, at 0 we have maximum value 1, and at 180 degree we have minimum value -1. If two vectors are quite close to each other, the gap between them or the angle between them tends to 0 and cos value tends to 1. So in this case we can say these two vectors are highly related. If it tends to 0, that if it tends to -1, that means they are highly unrelated. So let's see example of this cosine similarity. So in this example here, what I'm doing, I'm comparing two words, so the word king and cloud, and I'm generating two list or two matrix for these two words, and then I'm using this function cosine similarity. So this function is coming from this package here. Alright, So let's run this last step. As I run this last step, I get this the cosine similarity between king and word cloud is 0.7854. Now let's use another word. If I use word queen here, we know that vector king and queen are quite close to each other. Then their value would be in 0.9 or something. So if I run this step and then run this final step, you will see value is 0.9152. so this is another application of embeddings. So in this application we are finding how two words are related to each other, and this could be useful in another cases. For example, if you want to predict a next word, let's say I like apple, which we have seen in first segment. So what would be next word? Okay, I like apple juice. Okay, so this is how embeddings are going to help us. Now let's see one more application of embedding. So in this example we are going to solve a clustering problem. In this case we have a list of word and we want to cluster these word into similar group. For example, these are fruits, these are furnitures, and these are vehicles. And the example I'm using here is this. First let me clear this out. Here I have this input of tokens and the values are king, queen, apple, orange, bus, bicycle and motorcycle. If I had to categorize them into similar group, first I need to create embedding for each of these words. So in this response we are going to have embedding object, and in that embedding object we are going to have embedding for each of these words. So after creating embeddings, what we are doing, we are iterating through each embedding and we are adding that embedding into this list, and finally we are using k-means method. K-means is used for clustering so that we can create groups with similar object. Okay, so right now k value is 3, that means we are going to create 3 groups, and here we are passing those embeddings. Alright, so let's run this step and let's run this last step. You will see value 0 is assigned to apple and orange because they are fruits. Value 1 is assigned to bus, bicycle and motorcycle because they are vehicles, and value 2 is assigned to king and queen because they are peoples. Okay, so this is another application of embedding. Alright, so these are very simple applications of embeddings. Obviously you can create more advanced things with the help of OpenAI API's embedding. Okay, so if you want to get access to these examples, there is link in description.